Hey guys, welcome to 0.5 Debugging 101. So in this lesson, we're going to learn to use some coding maintenance conventions. We're going to fix some syntax, logic, and runtime errors, and we're going to learn what those are. We're going to understand syntax and crash error messages, and we're going to learn how to step through our program to find bugs and errors, things that are keeping our program from working properly. Okay, so syntax errors are problems with the format of our code. So one example of this would be failing to indent a block after using a statement that requires one. So if we typed 4x in range 3, then the Python interpreter would look at that and say, hey, where's my block, right? So that's why we have this little curvy red line. It's expecting a block. Another one would be if we left out brackets when calling a function. So the print function, right, has brackets, needs brackets and an argument, and we have the argument, but we left the brackets out, and so it's highlighted that for us too. So one key thing to remember here is that syntax errors, well, you discover them as you're coding rather than when the program runs, which is the case with logic and runtime errors. And this is really nice because it means that we can fix a lot of problems with our code as we're coding, right? The IDE helps us to write code that at least syntactically is correct. But most of your time fixing errors while you're coding will be because of bugs. And you'll be debugging, right? And that's because of something called runtime errors. So these types of errors don't show up while you're coding, like syntax errors. Your syntax will actually be fine, but rather when the program is running. And there's really kind of two categories. Some runtime errors will crash your program, just cause it to stop and be like, whoa, what just happened? While others will just cause it to misbehave and not necessarily crash, but do something unexpected. So let's look at crashes. So when your program crashes due to a runtime error, you're going to get an error message, just like you do with syntax errors if you hover over it nearby. So let's look at an example here. Let's cut this code and paste it into VS Code. I've created 0.5 note.py. Make sure you do the same. Mine's all spread out here, so I'm just going to delete all these spaces, and we'll just put a little comment in front that says example 1 crashes. Okay, so let's run the code. We'll press F5. And so because it says enter your name, we'll type that in, Barry. And enter your age, 31. All right, and you'll notice that we got some output here. What we got was, well, print A on line 4, we see Barry. Print B, which was our age, so that's 31. But then we got an exception, a type error specifically. And the error is can only concatenate string, not integer, to string. And you've seen this before, right? This is a type error because when you use this operator, right? And when we have a string plus something, that something needs to be a string. And so we've got a type error, and this is a crash. And the thing here to recognize is that, right, there is actually no problem with our syntax, right? Print bracket A plus B, close bracket, is perfect syntax, but because A and B contained data types that were different, the interpreter was unable to add these things because there is no way to do it. Let's look at another type error. So let's stop the program and we'll start Python in the terminal. So what we're going to do is just type this here, round, and we'll give it a string, 5.68 in single quotes, comma 1. Press enter. You see here that we got, again, another type error because string doesn't define the round method, right? We've passed the wrong data type to the round method. Now, of course, if we type this as 5.68, that is, we give it a float instead of a string, then you'll see that it gives us 1 decimal place. And so the round method works like this. You type round, you pass it a float with a certain amount of decimal places, and you say, then the second argument is the number of decimal places that you want the round function to round your float to. So we asked for 1 decimal place, and so it rounded it up to 5.7. So another common runtime error is called a name error. And this is something the computer gives us when it encounters a variable that has never been assigned a value in any of the code that comes before it. So here is an example. So let's cut, paste, and run the following code. Select this, and we'll paste it here. Again, let's get rid of some of these blank lines, and we'll call this example 2 name errors. There we go. So let's look at this for a moment before we run it. And of course, we'll comment out this first one so that when we do run it, it will work without any interference. Okay, so we have for I in range 1, 101. Now, I'm not sure if you've seen a range function before with 2 parameters, but when you have 2 of them, what you're actually doing is the first one is the start parameter. So range will go from 1 to the number less than this number. So 1 to 100 is what we will get. So 100 numbers total. So then in our for block, we have if I modulus 2 is equal to 0. That is if it's a multiple of 2 or if it's an even number, right? Because we're going to count even numbers between 1 and 100. Then we're going to assign count to count plus 1. In other words, we're going to increment the value of count. In other words, make count 1 larger than it was before. And at the very end, after that's done running, we will print there are count even numbers. So what do you think about this little example here? And see if you can predict what the problem will be. So let's run this problem. And as you might expect, we're going to get a name error when the interpreter tries to do this. So here we go. Exception has occurred, name error, name count is not defined. And it's showing us on line 12, count equals count plus 1. So here we are, right? So here's the deal, right? The first time that this variable is encountered by the interpreter, it's in an assignment statement, which is actually fine. But the problem is that the assignment statement is referencing itself. So we're saying that count is equal to whatever count already includes, whatever it contains, plus 1. The problem is that count doesn't contain anything yet. So the Python interpreter is looking for the variable count in memory and saying, you haven't given me a value yet, so I don't know what count is, if that makes sense. So think for a moment about how we could fix this. So the way to fix this, of course, is to give count a value, a starting value. And whenever you introduce a variable in Python, you need to give it a value, something that can be evaluated and will result in some sort of data type. In this case, count is going to be an integer, and we want to start it at 0 because as we count through all the numbers between 1 and 100, which is what this for block is going to do, we want to increment or add 1 to count every time we run into a value of I. In this case, that will be an even number, right? So, so the first time we get it will be, of course, when I is 2, because then I modulus 2 will be 0 and count will be incremented by 1. So let's run this now and see what we get. Aha, look, we got another exception. So in this case, we got a type error. And again, it's asking us to help fix this concatenation problem. So count is not a string, and so we need to convert it to a string. Let's do that, and we'll add str count. Now we should have fixed all the runtime errors in this code, and we'll run it one last time. And look, we got there are 50 even numbers, which should make sense because we're going to be going 2, 4, 6, 8, 10, all the way to 100. So the next type of error is called a value error. So a value error happens when a function is called with a proper data type, but with an argument whose value can't be properly resolved. And what I mean there is that the function just can't do its job with the argument that you gave it. So here's some examples. Let's fire up the terminal again, and we'll type int string 4. And so when we type that, of course, we get the integer version of the string 4, right? But let's let's try int a, right? We'll do the letter A. And here, of course, we get a value error, and it says invalid string literal for int with base 10a. So in other words, it's saying I can't make an integer out of a capital A. Like, what's going on? So that's what a value error is. Now, in both cases, right, we had a string, but because int was unable to convert a to an integer, we got this value error. So this brings us to the most frustrating type of error called a logic error. And these happen when your program isn't crashing, but is not performing the way you expect it to. These are also bugs because they happen at runtime. And they're the hardest to fix because you literally don't get an error message. Your program just misbehaves somehow and does something you don't expect. And I've got this frustrated guy here showing how painful this can be for programmers. And this is a true story. Not too long ago, my developer cousin spent over a month trying to fix just one of these problems. So here, example 3 gives us a good logic error. So let's paste this into our editor. And oh boy, look at all the spaces. So we'll just go ahead and delete all these extra spaces. At some point I'm going to figure out how to do a better job of supplying this code. And we'll call this example 3 logic error. All right. Now let's look over this program for a moment. So what happens is we're importing random, and we're getting 2 random integers from 1 to 10, and we're storing them in the variables number 1 and number 2. And then we have this print statement, and it's saying what is string version of number 1 plus string version of number 2. In other words, what is number 1 plus number 2? And then we're getting an answer from the user, so we're storing that in answer. And then if answer is equal to number 1 plus number 2, print correct. Otherwise, print nope, the answer is string version of number 1 plus 2. So let's run the program. And it's saying, what is 4 plus 7? So we can type in our number, and we get, oh, interesting. Well, nope, the answer is 11. So why is this happening? Well, what I encourage you to do again here is pause this video and look over this program and see if you can figure out what is going wrong. See if you can find the logic error. So you probably didn't find the logic error here. It's very well hidden. And it's cool because this calls for some heavier tools, debugging tools that I'm going to teach you how to use next. So scroll down here in your lesson. And so what we're going to learn next is called tracing, or stepping through our code. And what this lets us do is execute the code line by line to track the progression of the code and the values of the variables as we go. So for some reason this debug console here is not already highlighted and you don't see this pane, be sure to click this here so that you can see our debugging tools on the left. And let's also make sure to disable example 2 so that we can really just focus on example 3. So what we're going to do is put a breakpoint in our code. So right beside line 17, your line number might be a little different depending on what you've got above it, but you're going to put this little red dot you're going to see that you see when you hover over this space to the left of the lines here. You're going to put a red dot right there, and what that means is breakpoint. We've set a breakpoint on line 17. Now what happens when we run the program, if we press F5, you'll see that the program starts to run but stops here at line 17 and is ready for stepwise execution. So line 17 hasn't actually executed yet. This yellow arrow means I'm about to execute this line as soon as you press the step button, as soon as you take a step using our debug tools up here. Now, before we start stepping through, we should just take a moment to familiarize ourselves with the different ways that we can step through the program. And I've got an outline of all 6 of these buttons up here. And what they do. So we'll just quickly go through them. The first one is continue, right? And this is shortcut F5. What this will do, really, if you press that right now, is it will actually just resume running without stepwise execution at all. So if you press this, the remainder of the program will execute because there are no more breakpoints here. Now we could actually put in another breakpoint there. And if we did that, then after we click resume, press F5 again, it'll stop here. We press continue. Now it'll do all the code in between, and of course, it's waiting for input, so we can type it in 12. There we go. And then it will stop here again, right? Which was the next breakpoint. This is good for kind of like setting target areas where you want to actually debug the code instead of stepping through the whole program. If, for example, your code was gigantic. So let's just turn off that breakpoint and we'll stop the program again and we'll run it so that we have execution waiting to go at 17. So the next one is step over. This is F10. Okay, this is the one with a little arrow that's kind of bending upward and down. And what this is just taking a normal step without moving into any functions or any code that's contained within that statement. Now, this will make more sense later, but to summarize here, what that means is we just want to know the value of whatever we see without going deeper into the program if that value is evaluated somewhere else in the program. So if you click step over, you'll see that the execution proceeds line by line. Now you can actually do the same thing with step into, right? What this will do, however, is what is 2 plus 3? We'll press enter. Is go into. It'll take a step, but it'll go into any function or any sub piece of code that's sitting somewhere else in the program. Now, in this case, we have none of that in our program, right? Our program, all our code is right here in front of us. And so either of these will work the same way, step into or step over and step into. So I'll put this back up here. So step out, shift F11. This is kind of like the opposite of step into. So if we've previously used step into to go to a place in our code where we need to execute a series of lines before returning back to our current location, then we can actually use step out to get back out to the place that we just were. And once again, we're going to use these more once we're writing functions and we have code that's kind of like in different places in our program. So don't worry too much about that. Focus for now on this one, step over. Finally, we have restart, Control Shift F5, and what that really does is just restart the whole program. So let's say we'd taken a few steps here, right? And we're on line 19. Well, we can click this or press Control Shift F5, and it will just it'll restart everything and bring us back here to the first breakpoints. Finally, of course, we've used this a couple times. We can use the stop button to just completely stop stepwise execution and bring us back to our normal coding screen. So let's use these tools here to figure out what's wrong. So we'll press F5 and we'll run the program. So this is the very first line where we're importing random. So if we press F10 or click step over, either way. So what's happened now is we've just imported the random module, right? And you can actually see over here that random just popped up as one of the variables that's available. Now let's press F10 again so that this number 1 is assigned a random integer. So if we do that, then when you put your mouse over the number 1 variable, you should actually see the value that it was given, number 9. Okay, now your value might be different than mine because these are random numbers. Press F10 again and number 2 should also get a value. We got 9 and 10. Okay, and so Next is the print statement, line 20. If we press F10, then we should see the print statement show up down here. And line 21, we'll press F10 again. And now, of course, it looks like the program has stopped, but really it's waiting for some input. So we can go down here and type in our answer, which is 19. Okay, and so stepwise execution continues. So we have this condition, right? If answer is equal to number 1 plus number 2, which we know are 9 and 10, we'll press F10 again. And whoa, right? We expected that to be correct, but actually, right, we jumped to line 25. So clearly, we have a problem with this line, with line 22, with our condition, because we wanted it to go there, right? But it went down there. So that's a good clue as to what's wrong. What we're going to do next is use the watch window. This is actually a little window where we can add variables and names that we want to monitor, whose values we want to monitor. So let's stop this. I'm just going to show you how to add some stuff here. So one way to do it is to just click plus. So you can type in any expression here whose value you want to watch. We're going to put in number 1. So we'll type number 1. Okay, and of course it says not available right now. We don't, in other words, the program does VS Code doesn't know what's in that because it's not running at the moment. Another way to add things, which is actually kind of quicker, is during the process of stepping through, you can actually just double click an expression and add, and go down here, debug, add to watch. Okay, and what that will do is the same thing. It'll add it. We also want this one, answer. So let's grab answer and add that to watch. And so now we have 3 things. Okay, now do you notice how the value that it's saying, it's giving us for number 1 and 2 and answer is name error. And that's because execution has not progressed yet to the point where those variables are defined, right? So that should make sense. Let's now press F10, and we'll, as we step through here, we should see right there, number 1 got 4, number 2 got 1, and there's the print. Now here's the answer. All of this is not available during user input. We'll type in our answer here, which is 5. There we go. And of course, answer got something too. But do you notice what answer has? Right? So number 1 and number 2 both have integers, right? But answer, of course, has a string, because remember, an input function always, right, returns a string. And so this is the clue here, right? Because in this next condition, clearly this was evaluating to false, right? Because it was going to the else block. And this is why, because if you hover over, you can see answer is a string. And number 1 plus number 2, well, that does equal 5, but a string version of 5 is not equal to an integer version of 5. That would never be true. So that is our logic error. So of course, how do we fix this? Well, now that we figured the error out, we can remove our breakpoint, and let's convert our input to an integer. And then our comparison statement, our condition, should work. Press F5. All right, what's 9 plus 6? We know that's 15. Correct. There we go. So we fixed our very first logic error. Congrats. So that's actually it for this lesson. There are a series of assignments on Replit, section 0.5, A, B, and C, where your job is actually to just fix the errors and make the programs run properly. So good luck with that, and we'll see you on the flip side.